Okay. Today we are starting the final two sections of chapter 10 over scientific notation. And so one of them is like writing numbers from standard form in scientific notation. The other one's titled writing numbers in scientific notation back in standard form. And so we're just going to do both of them together. So we may not get all the way through the notes today. That's fine. Tomorrow's a review day. Thursday's a review day. We'll definitely finish them tomorrow, and you'll have time to work on that IXL if you haven't already started it. Scientific notation. Some numbers are too long to write in standard form. Standard form's the way you typically write a number, where you have the ones, the tens, the hundreds, and a comma, then the thousands, 10,000s, and 100,000s, then a comma, and then your millions, 10 millions, and 100 million. Okay, so that's the way you typically write a number. For example, the U.S. national debt. It's a really big number. Currently, and still growing, 26 trillion, 835 billion, 869 million, 422,000, and it just went up. And so that's our national debt. That's a really long number, okay? Because we like to spend money that we don't have. Okay. Notice how I didn't say some numbers are too big to write in standard scientific or standard form, because numbers like this, which is really, really, really small, is also would be benefit writing in scientific notation. So it's numbers that are long. Standard form's a way to write really long numbers in shorthand way. Okay, like the average size of an atom is what we got here: tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. So 300 millionths of a centimeter. If I could take a centimeter on a ruler, divide it into 100 million sections, 3 of those sections would be the width of an atom. So a number is written in scientific notation when it's represented as a product of a factor and a power of 10. We have a base 10 number system, which means every time we slide the decimal point, every column is 10 to the first, 10 to the second, it's a power of 10 greater than the previous column. Okay, that's why we can just add zeros when you multiply by 10, or slide the decimal point over. It's probably a better way of saying that when you times by 10. Same with dividing by 10. You just slide the decimal the other way when you divide by 10 or 100 or 1,000. So this is what it looks to write a number in scientific notation. Do you have a black box on your notes? That was weird. Okay. So you've got a factor. So that's the number that's being multiplied to 10. It's called a factor. Okay. That's greater than or equal to 1, but less than 10. 8.3 qualifies. And then you're going to always multiply it by 10 to the power of, and then that's where we have to count how many times we would move the decimal. In this case, 7 times. -7 tells you the direction you're moving the decimal point. So again, that factor must be greater than or equal to 1, but it has to be less than 10. And the reason for that is because if you could write it as 10, you could have just slid the decimal point over and made it a 1, and then increased the exponent on the 10. Okay. So numbers between 1 and 10, 1 included, 10 not included. Person?
Numbers that have like a lot of numbers, and I guess like US debt thing, that wouldn't moving the decimal place make the number like the same amount of length, just have the decimal place.
So what you would do is you would round it. Like we might say 26.8 times 10 to the power of 13. Okay, that's a good question. Yeah, we're gonna round ones that are like, if there's no like a bunch of zeros, like this one here has a bunch of zeros, we could just do 3, right? Yeah, this one we'd have to just round it to where we just say 26.8. Okay, so how it works. Each place value is a power of 10. So the exponent moves the decimal that many places. If you have a positive exponent, you're going to move your decimal to the right. because that number should get bigger. If you have a negative exponent, you're going to move the decimal to the left so that it gets smaller. We've talked about negative exponents before. We know negative exponents reciprocate your number into a fraction. Fractions are smaller, and so it makes sense that we'd move to the left to get a smaller number. Okay, so in this first example, I want you to tell me, is this number written in scientific notation? And if not, we're going to change it. By the way, on your homework tonight, on section 10.5, you're going to have questions where it says, is it written in scientific notation? I'm going to add the additional step of having you rewrite it in scientific notation, even though the Big Ideas doesn't require that. I want you to go ahead and do that so you're ready for your test Friday. Okay. So this is what it looks like to be in scientific notation. Is example A in scientific notation? Xander?
No,
No. Why not?
because it's less than 1.
Correct. Your factor has to be between, we'll call A that first number, has to be between 1 and 10. It can be equal to 1, got to be less than 10 though. Okay, this one's not between 1 and 10. So what we would do is slide the decimal point over and make this a 9. That's between 1 and 10. But that's going to change your exponent. If you increase the decimal place, you're going to have to decrease the exponent by 1 to make it to the 7th power. If you do 0.9 times 10 to the 8th, or 9 times 10 to the 7th, you'll get the same answer. But only one of them is actually written in scientific notation. That's the one that has the 9, not the 0.9. Okay, so they're the same value, but only one of them is written in scientific notation. Example B, 5.9 times 10 to the negative 6th. Is this written in scientific notation? Carter?
Yes.
Yes, it is. The 5.9 is between 1 and 10. It's then written times 10 to an exponent. That's exactly what it means to be written in scientific notation. They call it scientific notation because a lot of things you study in science. Now, science is a very broad category, right? There's a lot of different branches of science. Mathematics is a branch of science, just like astronomy is, and biology and earth science and physics and chemistry, and these are all branches of science. A lot of the things you study are really, really, really big or really, really, really small. Obviously, like at the molecular stage, you look at atoms and molecules, you're looking at really, really small things. Or you could be studying planets and the distances between planets. And those could be really, really, really big numbers. And that's where scientific notation kicks in, where you can write those really, really, really big numbers shorter, right? In a shorter way, just writing as a power of 10. 7 times 10 to the 0. Is that in scientific notation? Brady, why not? Can it not be? The power of 10 has to be an integer exponent. Okay, is 0 an integer? Yes, yes it is. So that qualifies. Was 7 between 1 and 10? Yes, so this is in scientific notation. Now, Brady, what is 10 to the 0 power? And 7 times 1? So this is the number 7. You probably wouldn't write the number 7 in scientific notation, considering that would actually make it longer than what it would normally be in standard form, right? But if you had to write it in scientific notation, this is exactly what you'd write. 7 times 10 to the power of 0. And the last one, 10.2 times 10 to the negative 4th. Jimmy, scientific notation or not? It's not. What would you need to change the factor in front of the 10 to so that it's between 1 and 10? So what would you write? Got it. Yeah. So we're going to slide the decimal backwards. I call that decreasing the decimal. And if you decrease the decimal to make up for that, you'd have to increase the exponent. So it cancels out. Sky, what do you get if you increase -4 by 1? That's right. So 1.02 times 10 to the -3rd. So is everyone clear on tonight's homework, 10.5 section, when it says, is it in scientific notation? Anytime you answer no, I want you to go ahead and write it just like we did right here. That's all I need. Okay, just so we're ready for the test. Okay. These numbers are all in scientific notation. Someone take the charger that was plugged into the wall up here. That's yours. I don't know. When was it last plugged in?
Last period I saw it.
Someone might have grabbed it on the way out. That was in your class. Okay, check to see if it's one of those. These numbers are all in scientific notation. What we're going to do is write them in standard form. Okay, this is really easy. In fact, you might find this quite fun. The exponent tells you how many times and what direction to move the decimal point. Because this is a negative exponent, we're going to move it to the, do you remember, Jimmy? To the left. How many times? 4 times. We're going to move it 4 times to the left. 1, 2, 3, 4. Sorry, I don't want to write over my letters there. Now that means I'm going to have to add 1, 2, 3 zeros in there. So this would be 0.00032. You could also put a 0 in front of the decimal point if you want to. You don't have to. It's not going to be wrong if you don't do that. So this is the tenths, hundredths, thousandths, 10,000s, 100,000s, millions. We'd say 322 millionths. I kind of like 3.22 times 10 to the -4th. Okay. Example B. Emerson, how many times do you have to move the decimal point? Okay, let's back up. Not 6 times, not 5 times. How many times did we move this one, Emerson? We moved it 4 times. Okay. How many times are we going to move this one? 5 times. Okay. Now, because it's +5, what direction are we going to move it? Christian? To the right. So I'm going right 5 times. 1, 2, 3, 4, 5. That does not mean I add 5 zeros though, because one of those moves was just to get around the 9. So we ultimately end up just adding 4 zeros. And it would be really helpful to me if you go ahead and put your commas in there. I think it's also helpful to you because if I had to have you say that number, I don't want you to say 790,000. I'd want you to say 790,000. Okay, so put those zeros in. I wish we used commas when we did decimals, but we don't use commas when we write decimals. You just kind of have to count. Okay, so just to be clear on this, the exponent tells you what direction you're moving it. To the left if it's negative, to the right if it's positive, and the number of the exponent tells you exactly how many times. So we did move this one 4 times, but the first move was just to get around the 3. That means we need 3 more zeros. All right. Example C. 6 times 10 to the 7th. Last time we had a decimal. It was after the 3, or in this case, it was after the 7. There is no decimal point here. Jacoby, where is the decimal point? In front of the 6. Right there. No? Okay. So not there? The other side of the 6. Yeah. 6 or 6.0 would be the same thing, right? So you can put the decimal in. We still have to move it 7 times. Now, because this time I'm not moving it around any other digits, I am actually going to add 7 zeros. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. On your work papers, please tidy it up. Don't leave that as the answer. That can be your work. Don't leave that as the answer. Go ahead and tidy it up and make it 60 million. And then example D, 1.285 times 10 to the negative second. Julia, tell me what direction and how many times I'm moving the decimal point. 1, 2. How many extra zeros do I need? Just one. That's right. 0.01285. And that's scientific notation. That's going from scientific notation to standard form. The next lesson was going to be going from standard form to scientific notation. Makes sense just to talk about it today. Before we get there, though, they're going to give you some story problems that involve scientific notation. Sciencey story problems. I like these. An object with a lesser density than water will float. An object with a greater density than water will sink. What is that called? You studied this before, Owen? Buoyancy. That's right, buoyancy. Yeah. So if it's less dense than water, it floats. If it's more dense, it's going to sink. Use each given density in kilograms per cubic meter to explain what happens when you place a brick and an apple in water. I bet you probably already know. So if you're going to compare numbers that are in scientific notation, they have to have the same exponent. If you're going to compare numbers in scientific notation, they have to have the same exponent. So if you look at the first two, they're both times 10 to the power of 3. So then I can look at the factor. Is 1 or 1.84 bigger? Owen? Yeah. So the brick is going to sink. It's more dense. The apple looks like it's more dense, but it's times 10 to the power of 2. So if I wanted to increase, so it matches and has a power of 3, if you increase the decimal or the exponent by 1, you got to decrease the decimal by 1. They work in opposite of each other, okay? So this would be 0.641 times 10 to the third. Now I know that's not in scientific notation, but I'm converting it out of scientific notation so I can compare it to the other ones that are in scientific notation. Which is bigger, 1 or 0.641? So this is less dense than water. And what's that mean? Julia? Yeah, the apple's going to float. That's why they have bobbing for apples, right? You don't have to go all the way down to the bottom of the barrel. They're floating at the top there. Okay. All right. A dog has 100 female fleas. How much blood do fleas consume per day? That's a morbid question. A female flea consumes about 1.4 times 10 to the negative 5th liters of blood per day. You're going to be multiplying that by 100 fleas. So 1.4 times, what was it, 10 to the negative 5th. That's how much blood, liters of blood. Now that's a small amount because this is to the negative 5th. That's a small, I mean, it's not a full liter by any means, but there's 100 fleas. So we're going to times that by 100. Now what is 100 if I wrote it as a power of 10? Carson? Okay. And knowing what you know about exponents, what would 10 to the 5th times 10 to the 2nd be? Oliver, what's 10 to the 5th times 10 to the 2nd? That's right. So we'll say 1.4 times 10 to the negative 3rd liters. And if you want to write that in scientific notation, you'd move the decimal how many times? How many times? 3 to the left. And that would give us an answer of 123.0014 liters. Again, very small amount of a liter. A liter is pretty big. Yeah, Julia. These dogs probably are not using a litter box. Thank you. There we go. Liters. Does your dog use a litter box? Okay. Now, when you're in high school and you're using a graphing calculator, that's a bigger screen, you're going to see numbers like this. The E means exponent of 10. So it's really writing it in scientific notation for you. Okay. So if you were going to write that in standard form, 8.73 E16 means times 10 to the 16. So you're going to have to move the decimal 16 times to the right. Now, if you're wanting to save yourself some time, just think how many zeros that would be. The first two moves would be to get the decimal around the 7 and the 3. How many additional moves would you need to make, Sky? That's how many zeros we'd need, 14. So 873. Again, the first two moves gets you around the 7 and the 3, and then we need 14 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Put your commas in. We've got the hundreds, the thousands, the millions, the billions, the trillions, and I guess that would be the quadrillions. 87 quadrillion, 3 trillion, 300 trillion. It's pretty big. Your scientific calculators, I know they're not graphing calculators, but they also do scientific notation. Okay. Try doing, let's just start with the number 2. Type 2 on your calculator. Small. Okay. You have a squared button, right? Square 2, what do you get? 4. Still pretty small. Square that, what do you get? 16. Square that, what do you get? This is taking off. Square that, what do you get? 65,536. Square that. I just reached the end of my decimal limit. That's a really big number. That is 4,294,967,296. Square that. Do you see it say times 10 to the 19th now?
Yeah.
Now you know what that means. It means all of those digits, and then not 19 more zeros, because you'd have to move the decimal 19 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 digits after the decimal point. So I guess there'd be 10 more zeros after that. And they're not all zeros, but we have to round your calculator around digits. They're actually number values, but at least you know how many decimal places it would have, right? Square it again, sure. Times 10 to the 38, square it again. This is going to be it, right? Oh, times 10 to the 77, square it again, and overflow. Your calculator says, I'm not smart enough for that. Or, well, I don't have enough room to even display the exponent. The exponent got so big, I can't even display that. All right. Write each number in scientific notation. Google purchased YouTube in 2006 for $1,650,000,000. I wish I would have come up with YouTube. Been not teaching at this point now. I'd probably be sailing in a boat somewhere, except today wouldn't be a good day for it. All right. So we've taken numbers that are in scientific notation and written them in standard form. This one's in standard form, and we're going to write it in scientific notation. So knowing that your first number, remember there's always a number here, and it has to be times 10 to the some exponent, right? Knowing that that number here has to be between 1 and 10, there's only one spot that I can put my decimal point. It's right there. 1.65 is what I'm going to call this. So 1.65. Then you're going to have to count how many times you moved your new decimal point back to its original location. 1, 2, 3, 4, 5, 6, 7, 8, 9. Did you move it to the right or to the left? To the right. So it's times 10 to the positive 9th. That makes sense. If you have a big number, it should have a positive exponent. Yeah, Sander.
On any quiz or test, would it be acceptable to put 1.65 E9?
Yeah, don't write it in calculator form. Write it in scientific notation, which includes the 10. That's a good question, but yeah, don't put E9. Yeah, don't let, that's just what your that's what your graphing calculator would say. Not even your scientific calculator does that. It actually does put the times 10. Most of them do. All right, in 2004, or in 2004, the 2004 Indonesian earthquake slowed the rotation of the Earth, making the length of a day 0.0000268 seconds shorter. That's where all my free time's going. Okay. So we're going to write that in scientific notation.
Curse you, Indonesian earthquake.
Darn that earthquake. Where do I put the decimal point after what number? Lizzie? The 2. Yeah. So we'll say 2.68. Okay. I can't put it after the 6 because it'd be 26.8. You know, it has to be between 1 and 10. I can't put it before the 2 because that's not bigger than 1. So there's only one spot I can put the decimal point. Times 10. And then count how many times you would move the decimal point back to its original location. 1, 2, 3, 4, 5, 6. What direction did I move it? To the left. So to the -6. It's easy. Really, the only thing you could possibly do to make a mistake is miscount or forget if you move it left, it's negative. Right? Shane.
It's like almost.
With technology that I don't understand. That's probably a good enough place to start. I know that we're not, this is about half, is this like the halfway point? Slightly over the halfway point, but use these 2 examples. For those of you that want to get 10.5 done tonight and start 10.6, 10.6 is just going to have you do it the other way around. You just take a number that's in standard form and write it in scientific notation. We'll stop here today.
Basically, that's all we need to know for the class.
That's all you need to know for the first 2 days. Yeah, for the 2 lessons here.
Wait, why are we doing the second?